All right, welcome to week 5. This is video 12 on race and pain management. So I want to start by going back to our primary story, the story of Henrietta Lacks. When Henrietta Lacks died, she was in a lot of pain. When she was near death, her cousin Emmett and some friends came to see her to donate blood to her. While he's visiting her, she has a seizure. And he says that she rose up out of that bed wailing like she'd been possessed by the devil of pain itself. He goes on to add that them cells of hers were something else. No wonder they could never kill him. Cancer is a terrible thing. So Henrietta Lacks was in a lot of pain. Interestingly, her cousin had come to donate blood because the doctors had stopped giving her blood transfusions until she, quote, settled up her debt with the blood bank. This was before they'd actually put her on palliative care only. And this sort of leads to a question that's looming in everyone's mind, right? How would have Henrietta been treated differently if she had been white? According to Howard Jones was the attending gynecologist. She got the same treatment that any white patient would have. And all the treatments that are recorded are standard treatments for that day. It's worth noting, though, that it's pretty well established that African Americans get less treatment for pain than white patients. And so that's what I want to focus on today. The fact that blacks receive fewer pain meds is pretty well confirmed at this point. The debate is really only over why and in what circumstances does this happen. For instance, some studies indicate that the discrepancy in pain medication only happens when the doctor is called on to make a subjective judgment, like if you're dealing with back pain or stomach pain that's hard to quantify. On the other hand, one of the studies that we're going to be looking at says that the discrepancy in pain management occurs even when there are objective diagnostic criteria available. Okay. So I've posted 3 studies that I'd like you to take a look at. These are scientific articles, and so they're going to be technical. And if you're not in the medical sciences, you're not going to be able to make sense out of all of them. And I don't expect you to. That makes sense of all the details out of all of them. But what I want you to get used to doing is looking at a scientific journal article and extracting the information that is relevant for you, and understand the different parts of the article and why it is the way it is. That way, you can become a better consumer of scientific information. And so really the goal here is twofold. We both want to understand a serious political problem, the undertreatment of pain in African Americans, and practice our skills at consuming scientific information. So I've got 3 studies here. Hoffman et al. From 2016, Goyal et al. From 2015, and Todd et al. From 2000. The first one looks at Hoffman et al. Looks at the role of false beliefs in pain treatment. Goyal et al. Looks at children with appendicitis and pain treatment. And then Todd looks at people with broken bones. So I'm just going to hit some details about these studies, and then I'm going to ask you to read them with certain goals in mind. Hoffman et al. Is perhaps one of the most famous ones right now because its findings were really quite shocking. So there was a lot of newspaper coverage about it, for instance. So the big finding right away was that many doctors have false beliefs about race, including really old 19th century slave era beliefs, for instance, that blacks have thicker skin, right? Doctors with these false beliefs, like blacks have thicker skin, were more likely to underestimate the amount of pain a patient was in, and more likely to prescribe fewer pain meds. So, when you guys are reading these individually, I want you to focus on this one. I've got questions about this one in particular because these are some dramatic findings, and we want to be able to pick them apart. The other two papers are pretty significant as well. So Goyle et al. Studied black children with acute appendicitis in an emergency room and found that black children were less likely to receive any pain medication for moderate pain, that is, just like Advil for moderate pain, and less likely to receive opioids for severe pain, suggesting a different threshold for treatment. And then Todd et al. Is one that I'm going to be going into in more detail in this presentation. Looked at black and white patients with long bone fractures, like your arm or leg, broken arm or a broken leg, and found that black patients were less likely than white patients to receive analgesics, to receive pain meds. Okay, so in order to understand how the scientists arrived at these findings, and we want to go back and do some basic scientific method stuff. So, as I said before, there's a lot of disagreement about what the scientific method is, especially among scientists when you're starting to drill down into the nitty-gritty of details and comparing how different disciplines work. Nevertheless, there's sort of a broad agreement that the scientific method is some kind of hypothesis testing. And I talked about this a little bit when we talked about the Tuskegee syphilis study. There, I mostly just wanted to emphasize the role of controlled studies and clinical equipoise. Here I want to go into more detail about kinds of studies and what can be inferred from them. Another bit of background, I am using what in the philosophy of science is known as the semantic view of theories. So under this conception, fundamentally what scientists do is build models. You hear a lot of talk about models in the COVID era because people are producing epidemiological models all the time. They consider whether to reopen a college campus, and then they produce a model of how COVID might spread on the college campus. On the semantic view of theories, this kind of modeling is fundamental to what science is. Science is fundamentally about creating models and then using hypotheses that link the model to the world. So models can be all sorts of things, and sometimes people actually deal with like physical scale models. When Watson and Crick discovered the structure of DNA, they were actually putting together metal puzzle pieces that they had made to see how the molecule might work. Analog models are important. And this is typically, an analog model is just an analogy. You use one thing as an analogy for another. And so if you've ever, when medical research is conducted on animals, these are models. These are animal models. So right now people are no doubt testing COVID vaccines on mice and then monkeys and then pretty soon humans, probably already humans. But these are, again, a kind of model. The models we're going to be looking at here are actually theoretical or statistical models. So they're just abstract. They're made out of words and symbols. In climate science, among other things, computer models are really important. Okay. I want to emphasize this. Models are like maps. Models are representations of the world, and they have a similar structure to the world, but they always simplify. Every scientific model is a simplified version of the world. If you were dealing with the actual world, you would just have the actual world, and it wouldn't help you. It would be like a map that is actual size. A map that is actual size that just says 1 mile equals 1 mile in the corner does you no good. Models have to simplify. And so the question isn't so much whether the model is true or false, but whether it fits the world properly for our purposes. So when we want to find out if one thing causes another, we use a randomized controlled experiment. And this is often, this term is batted around, and sometimes people outside of science don't always get straight what's going on here. But the idea is that we want to look for two groups, and the only difference between the two groups is that one has the possible cause and the other does not. So you select individuals at random to be in the study, and then you randomly sort them again into two separate groups. One of the things I emphasized about the Tuskegee syphilis study was clinical equipoise. This is a moral principle. This isn't a scientific principle. This is a moral principle. It is morally necessary for any human clinical experiment that you would feel equally comfortable in either the experimental group or the control group. And so this was one thing that was clearly violated by the Tuskegee syphilis study, because the people who were getting treatment were clearly better off than the people who were not getting treatment. All right. Ideally, we want a randomized controlled experiment, but oftentimes we're not able to do that, especially in medicine. So we've got two kinds of observational studies that can also be used as poor substitutes for randomized controlled experiments. One is what we call a prospective observational study. This happens when you identify two groups, one that has the cause already and one that does not have the cause already, and then you just observe what happens. You can think of this as, sometimes this gets called an experiment in nature. And the Tuskegee syphilis study was technically a prospective observational study because they found some people who already had syphilis and some people who didn't and just followed them. There wasn't any randomization or introduction intentionally of syphilis. You can do things prospectively, looking forward. You can also do things looking backward. So what you want to do is identify a group of people in the past who have been exposed to a cause and see what effects have already happened to them, right? So this is backwards looking. Okay, so the studies we're going to be looking at come in several different categories. But they're not actually, none of them are randomized. They're either going to be prospective or retrospective. Another thing we need to think about is the difference between the population and the sample. Studies are always done on a small number of people. And understanding the relationship between the population, which is the whole group of individuals you want to make inferences about, and the sample is really important. So a standard thing that they talk about if you take a course in stats or probability is a jar full of marbles. So the whole jar is the population. and then you pull some marbles randomly out of the jar, and that's your sample. In politics, your population is something like the people of the United States, and your sample is the people you contacted randomly via phone or internet. One thing that happens frequently is that there's actually a difference between the population you want to know about and the population you are actually sampling. So this happens all the time with animal models. For instance, a standard example I use here is the study that proved that saccharin causes cancer. The intended population was humans. We don't really care whether rats get cancer, right? The intended population is humans, but the sampled population were rats, right? And then from the sampled population, we draw the sample itself, which is even smaller. And in this case, it was going to be like 100 or so rats that are actually used in a lab. Sampling method becomes really important. And often one easy way that you can spot problems with scientific studies that appear in newspapers is by looking at the sampling method, right? So the sample is the people that you are actually studying or observing. The question is, how are they selected from a larger population? This is important. It used to be in political surveys that they would select names randomly from a phone book. And this worked because this is back in the day, probably before some of you were born. Everyone had a big yellow book with everyone's phone number in it. And that's less reliable now because most people don't keep phone books. Online databases of phone numbers are incomplete. People have plenty of interest in hiding their phone numbers from spammers. So how a sample is selected from a population is very important. And I'm going to look at 3 different kinds of samples. These are the 3 that you'll see most often. A random sample is what science is supposed to have. And a sample is genuinely random when each member of the population has an equal chance of being in the sample. That is the technical definition of a random sample, and it's meant to be very specific. A lot of times, though, what you see are not random samples, but what we call self-selected samples. These are samples where people choose to be in the sample. In politics, you get a lot of phone-in polls. So Fox News will say, dial this number if you think Barack Obama is Satan. And then lots of people dial that number. They choose to. And that is happening. That's not a random sample anymore. You are sampling the Fox News viewers who are motivated enough to pick up a phone and give their opinion. Self-selected samples also are really common in sex surveys. It's difficult to get people to talk about sex. So a lot of our information about sexual health, for instance, comes from people who volunteer to be in a study. And as it turns out, when you do it this way, it looks like you are going to wind up over-selecting for kinky. People with unusual sexual habits are more likely to be participating in these studies. And it's similar to the fact that people with strong political opinions are more likely to participate in political surveys when the sample is self-selected. The absolutely most common form of sampling in almost every science that involves human beings is the sample of convenience. Researchers choose the sample that happens to be accessible to them. This is why most psychological studies have historically been conducted on freshmen in Intro to Psychology courses. Freshmen in Intro to Psychology courses is a group of individuals that is easily accessible to any research psychologist. You may note, though, that freshmen in college who are taking Psych 101 aren't necessarily representative of the rest of the population. They're younger, they're already more educated, they're already wealthier, so that's a problem. Okay. When you study, when you are reading these articles, I've got 5 questions. And I'm taking these from a textbook called Understanding Scientific Reasoning, which I think is a helpful, it does the semantic model of theories, and it in general is helpful for being a good consumer of scientific information. So we've got a couple questions here. What is the intended population? What is the studied population? Who do they want you to make an inference about, and who are they actually studying? Then within the population that they're actually studying, what is the sample and how is it acquired? And then finally, we just want to name the variables correlated. And I can go into more detail. I sometimes go into more detail about identifying variables, but here I think it's going to be fairly straightforward and we're just going to do it simply. So I want to start with one of the articles that we read for, that we will be reading on pain management. And so let's just start by taking a look at the article itself. All right, so when you open a scientific journal article like this is just the PDF file for the article by Todd et al. It can look pretty daunting right away. The text often is pretty densely packed. That's a leftover from the days in which things were printed on paper, which cost money. There are lots of details that get listed. Sometimes these details are important not for us as lay consumers of science. They're there for people who want to try to replicate this study or want to know, to really criticize possible details for how things were done, right? You just need to learn to do is to go through here and look for only the information that is important for you. And that will sometimes require blotting other things out. So, for instance, in the methods section, they often will go into a great deal of detail for people who they would be needed if you wanted to replicate the study. But for our purposes, you just only need to know a little bit about the methods. So look right here. We conducted the following retrospective cohort study at an urban ED in Atlanta, Georgia. That's an important thing here. Remember I talked about prospective and retrospective studies? This is a retrospective study. And it actually is just in one emergency room in Atlanta. So that's the sort of information that you're going to want to pull out. Here's another important one. The study consisted of 217 patients, of whom 127 were black and 90 were white. So then they go on and give you things like the p-values. This is important for statisticians. We're not going to dive that deeply into this. We're just looking at a few basic details so that we can begin to understand how the results we're looking at were arrived at and how much we should rely on them. All right, so I want to go back to the questions I'm going to have you ask about one of our scientific papers. The intended population, the studied population, sample, sampling method, and variables correlated. So I'm just going to run through this with the Todd et al. Study, and then I want you to go back and do that with the study that suggested there was a correlation between false beliefs and inadequate pain treatment. So to begin with, what is the intended population? Well, in this case, the people doing the study are interested in doctors prescribing pain meds in a variety of situations. So what you see early on is that they initially did this study with pain treatment and Hispanics, and now they are trying to generalize it to African Americans. So the idea here is clearly that they are looking for a fairly general result, right? But once again, they don't study a general thing. What they are studying is doctors in one ER prescribing pain meds for broken bones, right? So they're looking at a single ER. What is the sample? Well, as we said before, the sample turns out to be 127 black patients and 90 white patients. And here we see that they were managed by a total of 37 different physicians. That gives you a sense that we're not just looking at the random biases of one or two physicians, but we are narrowing things a bunch. The other interesting thing here is to note that this study was conducted by looking at medical records. It's retrospective. They're not sitting in the ER waiting for people to come in and seeing what doctors do. All they have are the patient medical records, and they have winnowed them down. And if you go to the article itself, you'll see that what they did was they looked for situations where an independent radiologist can confirm that all of the people in this sample genuinely had broken bones. And they all had similar notations about pain in the doctor's notes, right? So what's going on here for a sampling method? Well, it's really a sample of convenience. Like research psychologists using college freshmen as their study subjects, here the people at the medical school are using patient records from a nearby emergency department. So in this case, we actually just have two variables that wind up being correlated. In the article, they go through and talk about a bunch of different information that they noted and gathered. But in the end, the correlation is between two variables. Patient ethnicity, which takes two values in this case, either black or white. Other ethnicities are excluded. And then pain prescription, which again is reduced to a binary, right? So that gives you a sense of where this information is coming from. Now, this study has some interesting implications, right? The doctors here are looking at patients who've experienced similar trauma, right? All of the patients have been matched. One of the things that when you do a controlled experiment is you want the two groups to differ only by the variable you're trying to measure. Randomization is the best way to do this, but in this case, they've just done it by matching. And you can see the patients have similar traumas for similar reasons. So actually, most of them just fell. There are a few assaults, car crashes, others, but most of these people fell and broke a bone. All of the patients have expressed the same amount of discomfort. The researchers for this give a handy diagram down here. So this is figure 2, steps in the patient-physician pain analgesic process. So it starts with a pain stimulus, like a broken bone. And then the patient then has an experience, what it feels like to be in pain. They express that to the doctor assesses the pain, and then prescribes a treatment. The way that the study is set up, it looks like blame for the discrepancy is falling between the assessment and treatment phase, because pain expression and pain stimulus have been matched. Now, it's worth noting that it's well-documented differences in other parts of this. So people really do have there are documented differences between ethnicities in how much people express pain. So one fairly well-known study is that Asian people people in Asia are less likely to report pain. And if you're dealing with an immigrant population, then depending upon how much the population is assimilated, that will determine how likely they are to report pain. But that's not what we're looking at here. Pain expression was the same and pain stimulation was the same. So it looks like the judgment here is about treatment. Now, the other study that I wanted you to look at, the Hoffman study, reports something different. The Hoffman study actually says that doctors are assessing the pain of patients differently. And so now one question is, why is the Hoffman study getting different results? So I want you now to ask some of the same questions I asked about this study, about the Hoffman study. And the other thing I want to ask about on that exercise is your experience communicating with doctors. And this is another theme running through this course. Part of pain assessment is actually based on the doctor's ability to communicate with you, understand what you're saying. And one of the things that we learn in this book, and you've probably learned in experience in general, is that doctors don't always listen very well. And that has a major impact on the quality of the medical treatment you receive. All right, so that's all I'm going to do for this study. Your exercise is going to be about the Hoffman paper, and specifically the second of the 2 studies in the Hoffman paper. And after that, we've got one more video this week for reviewing for the quiz.